moving on to page 3, we'll start with number 9. So we've got the diagram. They want us to determine the height of the tree to the nearest foot. I might just call this side here, I'm going to just call that T for tree. So the triangles are similar. We also have the sides here that are congruent, and those are congruent. So we can actually just know that this side here is half of that side. So that would get us right to the 80 feet. If you forget that, you can do that. You can set up a proportion. A couple different ways you could do that. You could do T over 120 equals 160 over 240. Multiply both sides by the 120 and you'll get T to equal 80. So a couple different ways you can do that one. Let's see, so for number 10, trying to find the value of x, and that we know that OP is parallel to NQ. So then we know that those sides have to be in proportion, and so we can set up a proportion, and again there's a number of different ways that we can do that. In this case the numbers work out nicely, so maybe you can figure that out just by kind of looking at it. Here's one way to set up that proportion. I could do x over 20 equals 9 over 18. Now of course 9 over 18 reduces, but which you could do, I'm just going to go ahead and multiply both sides by 20. Like I said, it does reduce. It's actually the same as 1/2, and then half of 20 is 10, so x equals 10. Like I said, the numbers work out, so you can see that one. Alright, 11, same kind of situation. We want to find the value of x. Since these sides are parallel, then we can set up a proportion. Again, there are a few different ways to do that. I might do x over 12 equals 24 over 36. And again, 24 over 36, that does reduce down. Let's see, so that does reduce by a factor of 12, so it would be the same as 2 over 3. So if you want to do 2 over 3 instead, and then multiply both sides of the equation by 12, those cancel out. 12 times the 2/3, we're really looking at 8 for that side. And again, if you don't want to reduce the 24 over 36, that's not a big deal. It'll all work out the same. That's what calculators are good for. Number 12, again, notice they label the information up here. I would suggest drawing it on the diagram so you can see that. Let's see, so LM is 18, NO is 4, and LN is 10. And they want us to find the value of x. Again, we can set up a proportion. There are a number of ways to do that. I would probably do this, x over 18. So keeping those values together, and then the 4 corresponds to the x, and the 10 corresponds to the 18. Again, 4 over 10 does reduce by a factor of 2, so that's the same as 2 over 5. Multiply both sides by 18. Does not work out to be, a great number or easy number there. Have the calculator help you out a little bit. That ends up being 7.2 for that one. And as we move on, now we are on the final page of the practice test. So starting with number 13 here, we need to solve this proportion. We do have some x's in the denominator, so I would recommend cross multiplication. So we would have the x times x plus 3, and then the 10 times the x minus 1. Distributing the x through, we get x squared plus 3x equals 10x minus 10. Now this is quadratic, so we'd want to get everything on the same side, so really we're looking at subtracting the 10x and adding the 10 to both sides. Let's see, so we end up with x squared minus 7x plus 10 equals 0. Now, if you want, you can use the quadratic formula on this. You can also factor it. With the x squared, it's not too bad. We know it has to be x and x. Of course, still equals 0 there. We're looking at the factors of 10. That would give us a sum of negative 7. So really minus 5 and minus 2. Then the zero product property says that if we have x minus 5 equals, or x minus 5 times x minus 2 equals 0, that can only happen if x minus 5 equals 0 or x minus 2 equals 0. Solving both of those, we get x equals 5 and x equals 2. Just like any equation, you can always plug those values back into the original, make sure that it makes the equation true. If you plug those in, it certainly would work out. But not a bad idea to check that as well. Alright, moving on to number 14. So we are reducing a map that's got dimensions 2 feet by 3 feet to fit to a piece of paper that's 8 inches by 10 inches. They want to know what are the dimensions of the largest possible map that can fit on the page. And there may be a few other ways to look at this, but here's what I would do. I would set up a proportion, and because the units match up, we can ignore those. So 2 over 3 for the 2 feet by 3 feet. Set that equal to x over 10. So what I'm looking at there is if I match the longer sides up, then how much would the shorter side be? And I would set up the opposite. 2 over 3 equals 8 over x. So I'd solve each of those to see what the shorter and longer sides are depending on what I match up. So with this one, I'd multiply both sides of the equation by 10. We get 20 over 3 would equal x. In this case, x is the shorter side, and so that would equal 6 2/3. So that fits. So we'd be looking at a 6 2/3 inches by 10 inches if we did that. If we try the other one, I would probably cross multiply. So we get 2x equals 24. I guess I could have used different variables since now x is for the longer side, but not that big a deal. Divide by 2, we get x equals 12. The thing is, the longer side can't be 12, so what would happen there is if you're trying to match the shorter sides up, then you're going to run out of room on the longer side and not be able to get to that 8 inches. So really what we're going to have is that the first setup is going to work where we match the long sides up, and so we'd have 6 2/3 for the short side, and then the long side would be 10. And that's what they wanted to know. What are the dimensions of the largest possible map that can fit on the page? And so then really the answer would be 6 2/3 inches by 10 inches is what we're looking at. So, moving on to number 15, we've got the two triangles. They want us to state whether they're similar. If so, we have to write a similarity statement and the postulate or theorem that we used. So if we look at these triangles, again we can see the shortest side, the kind of in-between side, and the longest side for each one. So if they're going to be similar, that would be the way that they would have to match up. So I would just draw or write an extended proportion and see if they're equal. So does 9 over 12, the two shorter sides, equal 12 over 16, the two middle sides, and do they both equal 15 over 20? And so if we look at those different fractions, 9 over 12 reduces down by a factor of 3 to 3/4. 12 over 16 reduces down by a factor of 4, goes down to 3/4, and 15 over 20 reduces by a factor of 5, down to 3/4. So because all those sides are proportional, then we can say yes, the two triangles are congruent, or sorry, not congruent, similar. And we have to do the similarity statement, so we have to name the triangles. I would probably call it PXM. And so that is similar to triangle WAL. And that's by the side similarity theorem. Alright, and here we go. Last question, number 16. They want to know the value of x. Really, we can set up a proportion here. Again, a number of different ways you could do that. I might do something like x over 2x plus 3 equals x minus 2 over x plus 4. Since we've got x's everywhere, let's go ahead and do a cross product. So we do x times x plus 4, and that would equal 2x plus 3 times x minus 2. Now we do have to find those products. The first one's not too bad. It's just x squared plus 4x. Box or FOIL this product. I'm just going to kind of come up with it here. So the 2x times x would be 2x squared. The 2x times the negative 2 would give me negative 4x. And then we get 3x here. So that'd be minus an x, and then the 3 and the negative 2 would give us minus 6. Now it is quadratic, so we do want to get everything on the same side, so I would suggest subtracting the x squared and the 4x. And let's see, then that would give us 0 equals x squared minus 5x minus 6. Again, if you don't like factoring, you could use the quadratic formula. This will factor, however. Just put this up here. So 0 would equal, people do tend to have a trouble with this particular combination of values. You have to be careful because 2 and 3 can be put together to make 5, but so can 1 and 6. You got to pay attention to the fact that it's a negative 6 here. So we need a positive and negative number rather than two negative numbers. So we'd really need a minus 6 and a plus 1. And so we would set x minus 6 equal to 0 and x plus 1 equal to 0. Add the 6 to both sides, we get x equals 6. Subtract the 1 from both sides, we get x equals negative 1. Now the thing with the negative 1, based on the context of the situation, negative 1 doesn't make any sense, because then these two sides here, well, this side would have a negative length, this side would also have a negative length. So distance or length can't be negative, so then the negative 1 we would actually eliminate. But the 6 works out just fine. Again, you can plug that in, find the different lengths, and all of the things work out as far as proportions and whatnot. So, but 6 is the only answer there. I know it seems like negative 1 would be an answer, but it actually is not. As always, thank you for watching.